what we're doing now is we have a cookie that looks something like this. And on the server side, when we receive this cookie, we make sure hashing 1 gives us this hash value. And if it doesn't, we throw it away. Now, does this really solve our problem? A little bit, but if they know we're using MD5, which is pretty easy to guess, it's easy to forge a cookie, right? You can just change the cookie value to whatever you want, run MD5 on it, append that, and now you forge the cookie. So how do we solve this problem? Let me show you. What we need to do is we need to have some secret knowledge here. So instead of hashing the number 1 into our hash, what we want to do is we want to hash a secret string plus the number 1 into a hash. So as long as this secret stays secret, a would-be attacker, even if they know our algorithm, won't be able to forge a hash. Because, remember, one of the properties of our hashing algorithms is it's very difficult to find two inputs that equal the same hash, or to find a specific input for a specific hash, and vice versa. So they'll see in our cookie, they'll still see a cookie, the browser will still see a cookie that looks like this, but instead of hashing this 1, we added an extra little secret. And as long as the attacker doesn't know this secret, they won't be able to generate the same hash. So let's build this functionality in bit by bit. There's one last thing in Python I want to introduce you to. So we've been using hashlib to run basic hashes. There's a second library specifically for doing message authentication called HMAC, hash-based message authentication code. This is basically a special algorithm. It's built into Python for when you want to combine a key with your value to create a hash. There's a series of different types of attacks where if you just put your key plus the value, you can find a collision by just kind of extending your value. And similarly, if you put your value and then the key, there's other attacks you can do. And HMAC is basically just an algorithm that looks something approximate like this. HMAC, a secret, a key, a hashing function returns a hash. So it'll look just like using hashlib, except it'll take an extra parameter for secret, which will incorporate in a secure manner. You could just use our hashlib function with secret plus value, and that'll get you pretty close. And for our purposes, it actually probably worked just fine. But HMAC is the proper thing to use here. Again, you can learn more about HMAC on Wikipedia or something. There's a wealth of information on what the algorithm actually is, but it's basically a special way of using a particular hashing function with a secret key. I'll show you that real quick in Python, how we use it. Okay, let's review some of the things we've talked about. If we were to make a hash the way we've been doing it, we'd use hashlib. We could create an MD5 of a string and call hex digest on it, and we get the hex output. We can use the HMAC library to accomplish something similar, but HMAC takes an extra parameter for a secret and combines it securely. We could say hmac.new, and we give it a secret, and we give it Udacity. We say hex digest. And we get a similar output, except this is more secure. Of course, we could have done something like this, secret plus Udacity, and as long as secret stays the same, when we verify, our algorithm will still work. But HMAC is just basically a more secure way of accomplishing secret plus Udacity. Let's use this new HMAC function and a new secret key to improve our make secure value function.